So welcome everybody. My name is Saarang. I'm from the Developers and Systems Club, DNS. This is a collab workshop with the Game Developers Club of SFU, and this is the first part in a series of Raylib game development workshops. So the two tools we're going to be using is Raylib and C++. A little bit about Raylib before we begin. Show of hands, has anyone used Raylib before? Is anyone familiar with it? Okay, perfect, because the target audience is for people who have never used Raylib before, so good. A little background on Raylib. It's a cross-platform open source software development library. It's used for mostly graphical applications and also video games programming. You could do a lot of GUI stuff with it. You could create like interactive applications, all sorts of cool things. It's very visual. And it does have support for other languages as well, not just C++, but its C++ toolkit is very extensive. And you can take a look at the source code at this link right here. It's open source, so feel free to go through that. And coming to Snake, I don't think there's a single person who doesn't know what Snake is. It's a super popular video game. It's a classic, one of the first video games, actually. Pretty straightforward. The player controls the head of the snake. You eat the food, the snake grows. Pretty straightforward. Everyone knows what Snake is. And this is what we're going to be building today. From scratch using raw C++. So we're going to need just three things. We're going to need an IDE, a compiler, and Raylib. Does anyone not have a laptop or a computer with them at the moment? Do you mind sharing it with someone if that's fine? Okay, sounds good. So we're just going to need an IDE of your choice. I'll be using VS Code. You can use whatever you'd like. We're also going to need a C++ compiler, and we're going to need Raylib. I'll show you how to get Raylib. So if you go to this link right here, I'll give you guys a second to type it out. It's github.com/dnsclub/raylib-workshop. And I don't think there's .git, but you could add that in the URL. It should work. So it will take you to this website. And let me just increase the size. So you're going to see some steps right here in our README if you scroll down. So what you're going to want to do first is clone this repository and just store it on your local machine. So I'm just going to do that. I'm going to open up my IDE. You can store it wherever you'd like. I'm just going to put it in my code folder. So I'm going to open desktop, code, and I'm just going to open a terminal. And I'm going to paste git clone and the URL of that repository. So what this is going to do is it's going to add the repository to your local machine, and you should be able to see all the files in there. I'm going to open this in a new window. All right, so let's just start with that, and I'll give you guys a couple minutes to do that. Also, this event is going to be photographed, so if any of you do not consent to having your photograph taken, please let any of us know, and we will make sure not to include you in any photographs. Yep.
What type of file do you open? Because you have to open a new file for the IDE, or is it just like?
So you just open the IDE. Are you using VS Code?
Right, I'm using VS Code.
Okay, so just open VS Code, open where the directory that you'd like to store this repository in, and just open a terminal and clone the repository in there.
Oh, okay.
Yeah. You should see something like this. So you're going to have all of these directories on the left. There's going to be a license, makefile, and readme. And if you open these, you should see some files in there. So for example, let's open main.cpp. You're going to see some text and all that stuff. Was everyone able to get to this step okay? Is anyone having any difficulty? All right. So assuming you all have successfully cloned this repo on your local machine, what we're going to need now is a C++ compiler, because we're going to be writing our code in C++ and we're going to be compiling it to our executable. if you worked with C++ in the past, chances are you already have a C++ compiler like G++ or Clang. Assuming you don't, it's pretty simple. I've put some instructions on the repository based on the operating system you're using. So if you're using Windows, just follow these steps to get G++, which is a compiler we'll be using. If you're on Mac, it's pretty simple. You just brew install GCC and type G++ version, and that should give you your compiler version. So I'll run it for Mac just to show you how it looks. So I'm going to do brew install GCC in my native terminal. I'm just going to open a new terminal window, and I'm going to type brew install GCC. So you're going to see some loading bars and stuff. Mine ended super quick because I already have GCC. Chances are for you it's going to take a while, but give it a couple minutes and it should be good to go. It should say GCC is already installed, and you can verify this by typing G++ -- version. And you should get Apple Clang version. It should give you some sort of version number, and that is essentially confirmation that, yeah, you've got your compiler. Is anyone using Windows or Linux? So for Windows, you could, if you already have a C++ compiler, not to worry. Do you have a C++ compiler? Okay, then that's all good. But if you don't, it's a little more, it's a little less straightforward. You got to go to this website and download the compiler from there and extract it and all that. But there's steps right here, so you should be able to follow that. And at the end, if you type where.exe G++, it should give you the somewhat same result that I got when I typed it into my Mac. So it should say G++ version something something. So yeah, I'm just going to wait for everyone to get a compiler, just make sure that's okay. If anyone needs any help setting that up, we have two volunteers, Arya and Sapar. They'd be happy to help you out. I'll also be coming around and checking how you guys are doing.
Yeah, please just raise your hand if you have a question, and we'd be happy to help.
Yep. Yep.
Yeah, it's not working out.
Okay. Let's take a look. Right. So oh, you don't have brew. Okay, so you're gonna have to install this program called Homebrew. Install. Usually it comes default for all Mac devices. Homebrew. So there's a specific command. You just put first. Yeah. Yeah, because that. So yeah, just copy that and paste it. Brew is super useful. You're gonna use it a lot in the future to install any kind of like terminal tool.
This is.
Oh yeah, you just gotta type your the root password basically. Yeah.
You have a question?
Okay, so it's just gonna get brew first. Will be created. Oh yeah, just hit enter. So it's just gonna get brew for you. This is gonna take a little bit. And once you get through, you should just be able to type brew install GCC. And G++ is combined with GCC, so you get both the C and C++ compilers combined.
Okay.
Hello, welcome.
Oh, is it?
Yeah, it looks like it's ready to go. Yeah, so if you type brew install GCC. Are you using like sort of different shell? Are you in a virtual environment?
Not really, no, I'm not. No.
Could you type brew up? Okay. Oh, you might have to close it real. So just.
It's like.
Yeah. Sometimes.
So quick terminal? Or?
Yeah. Just, so type brew up. One second. You copied this command, right?
Yeah, I did, yeah.
Maybe use an alternative to root.
Check. Yep.
This is just if I copy this.
Yeah, I can't just use GCC as for, if you really have library
I think that
I'm
comes
not
with.
actually doing that, I'm just using VDI directly because I can necessitate more.
Okay, okay.
Simply become
Right. So you know for a fact that machine is going to have some sort of C++ compiler. If you're sure of that, then, I mean, you could always check. You could type C++ version or something, and that should return a version for you. As long as you know you have that compiler and you can compile C++ code, you can use whatever you want. It's all standard. Yeah.
But can they like run the
Yeah, yeah, you can. As long as you can compile C++ code, it should be fine.
Oh. Let's see if this is experience.
Yeah, so for anyone who was late, we were just setting up the repo. So all we did was we cloned our Git repository and we downloaded a C++ compiler. So if you go to this link right here, github.com/dnsclub/raylib-workshop, you should be able to copy this first command in the README and clone the repository onto your local machine. So I'll just give everyone a minute. I'm assuming everyone has a C++ compiler at this point. Okay, so we can move on to the next step, which is we're going to be getting Raylib itself. So if we go to the Raylib repo, I would recommend right-clicking on this and opening it in a new tab, because if you click it, for some reason it just opens it in this window, so you can just have this for your reference. So open it in a new tab and scroll down to releases. So if you look on the right side, you're going to see Raylib v5. So that's Raylib 5. So just click that and go all the way to the bottom. And here's where the steps start to differ. If you're on Windows, chances are you're not going to have to do any of this. So if you're on Windows, just go to the repository and go to the code, and open up your terminal and type make. And if you're not seeing any errors, if there's no like errors or warnings or anything, you should see a game executable show up on your left side. So for Windows, you don't have to worry about getting Raylib, because the libraylib.a file that I've included in the repository is already Windows compiled, so it's ready to go for Windows. For macOS and Linux users, just follow me. So do we have any Linux users here? Is anyone using Ubuntu or something like that? Okay, so it's pretty, just replace the Mac commands that I'm inputting with these Ubuntu commands. Are you using Fedora or something?
No.
Okay, thank God. That would have made things a little messier. But Ubuntu, fairly straightforward. You can just do these commands right here. So once we go to Raylib, scroll all the way down, and for macOS users can click on this file right here, Raylib 5 macOS. And Linux users, I would recommend compiling it from source, because some of these tend to not work on your machine, but if you happen to compile it from source, you know for a fact it's going to work on your machine. So I'm going to follow the macOS route. I'll show you the source code installation in a bit. So I'm going to install macOS.tar.gz, and I'm going to open that using Finder, and I'm just going to extract it. So it's just going to give you a Raylib 5.0 underscore your OS. And inside that, you should see a lib folder. And if you expand that, you're going to see libraylib.a. So I want you to just copy libraylib.a and replace it in the local repository's lib folder. So the default libraylib.a file that comes with the repository, when you clone it, is configured for Windows. That's why I mentioned that Windows users, you don't have to bother, you don't have to do anything. macOS users, just delete the existing libraylib.a and paste in the new one that you just downloaded. And make sure it's in the lib directory. So just paste it here. Yeah. So now if we go to our terminal and we type make, you shouldn't be seeing any errors. So you'll notice this time there wasn't any linker command error or anything like that. So I'm just gonna give everyone a minute to do this. Yep.
Could you just go through
Sure.
how you would install it if you were on Windows and you wanted to use Raylib outside of this
Yeah.
repository directory?
So if you want to just have it installed on your machine, that you could use it in any projects in the future, right?
Yeah.
So you'd go down to the source code, and you'd extract this. So you should first download the zip file. On Windows, I wouldn't download the tarball, that wouldn't work. So download the zip file, extract it in your C folder. So that's your root folder for your drive. And then go to your terminal and navigate to that source code and open source. So if let's say for example on Windows, let's assume this is the C drive. So I'm just going to extract this here. And I'm going to open this. This is kind of small. Okay, there we go. And I'm going to open source. So you're going to see source. I'm going to open this in a terminal. So let me just open a terminal and cd into that. Oh, this is downloads. Whoops. So once you're in the source directory, it's gonna say that in your terminal. It's gonna say source right here. Once you do that, you're gonna want to type mingw32-make, or depending on whatever compiler you're using. This is assuming you're using the compiler that I asked you to download. So that would be the mingw 32-bit compiler. But based on the compiler that you install, there's specific commands that you can type to actually get stuff to install. I would type, in this case, mingw32-make platform equals platform desktop. This is a Raylib command, so platform equals platform desktop. That's a flag that Raylib gives you when you're building the source code. So once you paste this into your terminal, it should essentially just give you what we installed directly. So it's going to give you this, the one with the lib. It's just going to give you that. So that's all the compiling the source code does. It's an additional step. But yeah, it's going to configure it for your machine. Okay, just going to give everyone a minute to get to that. Does anyone need any help getting this far? All right. Yep. So, okay, so you need to cd into the actual project repo. So I would type cd and Ray, just type Ray, and then you can hit tab. It should automatically do it. Yeah, so just hit that. And now if you type make.
No,
Yeah, no problem with that.
but I
Okay,
have a compiler.
hang on. So could you open that? Expand that. Could you open source?
I'll follow the steps.
Could you click that? Okay, yeah, so that says, let's see what it says. The make is not recognized. Oh, you might have to type make.exe or something. The make file is, okay, before that, could you open the window like separately? So if you click file and open folder, and just open the Railroad folder right directly.
I'll follow all the steps.
Yeah, so just select folder. And yeah, just you can close that. That's the default window, VS Code. So just open a new terminal or click main. Yeah, it should open in the same directory. If you type make. Okay, so. So it seems like it's not able to recognize the make file. One sec, let me check the repo. Do you have a C++ compiler?
Yeah.
Okay, you do. Okay. Could you just copy that entire error and just look it up? Because I think it's. Have you used Makefile before in a class or something? Okay, so it's it probably needs to be pre-configured or something. Yeah. Oh, so you need to install the make package. install a package manager, for example, Chocolatey. It's a pretty famous package manager. So I would just install that and get make set up. So yeah, just copy this command. Yeah, or any terminal should go, like PowerShell or something. Oh, there's some keys at the start. Yeah, you just control C and try again. Yeah, right, you could right click and quick paste maybe, that should work. Yeah, so if you open a new one, rather than clicking control V, because sometimes that actually key logs the, yeah. Or you could use PowerShell if you have that. Command prompt sometimes adds keys to it. I don't have PowerShell. Okay, if you right click and try that. Okay, yeah, you can just also do that. Yeah, Windows is a little bit of a pain.
Hello.
Oh,
Is this
okay.
the
The Raylib Workshop, yes.
Yeah.
Okay, sorry.
Alright.
No worries.
Class just ended.
Yeah, no worries.
We haven't started the actual content yet, we're still setting up the repository now.
Okay, yeah.
Yeah.
Try to open up that link on your laptop and get everything installed, but then on the platform.
Okay.
Then you can copy.
Let's go back to, so you don't have PowerShell, right? So you can't use this command.
So it was okay.
Yeah, it's okay.
Oh, so wait, so okay, I guess you do need to add.
Everything you need to know is in the.
Okay, it's part of the commands.
Oh,
Yeah, just
But
the,
if you command control V, okay, yeah, just hit enter. Strange.
he makes his videos are pretty good.
Oh, okay, I guess you should start with the second. So yeah, just wait for that to install. Oh. Installation requires ed. Okay, so you gotta open command prompt as administrator. So right click on command prompt and, or if you click on start and command, just type command prompt and then run as administrator. Yeah, if you paste the command now, I don't think it should keep it that way. Okay, so it seems like you have it. So now if you type, if you go back to that, I think it's choco install mate or something here. Google. Yeah. So if you go back to this, I think it's choco install mate. So yeah, just try that.
This is what administrator support.
so it's in. You have to remove that. So if you go back to program files, just delete chocolate. Yeah, just remove that. And yeah, could I also check your environment variables? So if you type start, if you go to start and type environment, yeah, just open that. And environment variables. And path or system variables actually. Yeah, just path right here. And click edit. And okay, chocolate is not in.
Well, it's better.
So that's good. Could I also see the user? Yeah, just path. And just edit. Okay, so it's not in here. That's good. You could try now, and since we've removed the path, it should work. Okay, so it recognizes that the path isn't existing, so it's adding the path.
Oh, it's amazing.
Okay, so now chocolate should exist. If you type chocolate, stop me.
Maybe I should,
Okay, awesome.
I think every time I open it, it asks me to add the program, which is what
Okay, now if you go back to
Save.
the actual project and type make. Oh, you might have to reopen.
Yeah. It saves the files, but it doesn't save the log.
Wait, if you open command prompt, and if you see into this, so if you type ls, just type ls, or not, c, yeah, just call it. CD desktop.
No, it's collect two, it's got the
It
student.
should get probably not gonna work.
Oh.
Well, this is
One of the references to look on too.
cd dot dot. Just right there.
Usually that means there's it's happening on compile, right?
Trying to.
Oh, okay.
One sec. I'll just ask my friend if he knows. Oh, you use Windows, right?
No, I'll use those.
Oh, real, bro.
Separate users for those.
Could you help now with make? You guys know how to also okay, is there oh, is it because wait, this is Windows, isn't it? Oh, you're using the CSUM?
Yeah.
So that's Linux. Okay. So you're gonna have to reinstall Raylib basically. So I'll go over the Linux steps. Just follow over that.
Oh.
Sorry.
Oh.
Okay, so I'm just gonna go over Linux real quick. I'll open my VM up.
Try this, this time, try running PowerShell.
All right, so I'm just gonna open the repository on a browser. GitHub. Is everyone able to see this okay? Yeah. So for our Linux users, we're first gonna get a compiler. So assuming you all have, you guys already have a compiler already, all our Linux users? Okay, so I'm gonna skip that then. So we're gonna open our Raylib repo. We're gonna go to source code, so we're not gonna open the Linux tarball. We're gonna actually download the source code. We're gonna extract that in our desktop, or I like to put it in home personally, so I'm just gonna move that over there. Where is it? Okay, I guess this works. I'm just gonna extract it here. And you're gonna see source, so I'm gonna open the source folder. I'm gonna open this on a terminal, so open in terminal. And I'm gonna type that command, so it's, oops. Make platform desktop. I'm just gonna copy that. Oh boy. And I'm gonna paste it in my source directory. And what that's gonna do is it's gonna build Raylib from source, and you're eventually gonna get a lib folder with our static library file. So just give this a minute to finish. All right, so it says Raylib static library generated in source. So I'm gonna go back to my source folder, and you're gonna see the static library right here, lib raylib.a. So you're gonna copy that, and you're gonna paste it into your project window. I don't think I have it cloned, so I'm just gonna clone it real quick. Terminal, git clone, and we're just gonna copy this URL. Oh. All right, so once you're in here, this is not gonna run, of course, so if I were to cd into this repo, and I type make, of course, this is the Windows static library, so it's not gonna compile. I'm just gonna copy over this libraylib.a that we just obtained, and I'm gonna delete this, the Windows one, and I'm gonna paste it right inside lib. Right here. Well, my IDE won't let me, so I'm just gonna move it manually. Code the project repo, lib, and I'm gonna paste it right here. There it is. And now if I were to type make, you'll see that we're not getting any errors, so the static library is working for Linux. Was everyone able to follow with me so far? So does everyone get any errors when they type make, besides the Windows? Oh, okay. What operating system are you on?
Windows.
Okay. So you might have to install a package manager that gives you make.
I thought we have make installed.
Yeah. If you open like a PowerShell or something, if you type make, does it still tell you that it's not recognized? Okay, so apparently your system doesn't have make. You might have to install. So can you open the menu as a administrator? Okay. Yeah, PowerShell might. When you install stuff, it's always better to open it as an administrator. So run as administrator. Okay, so make isn't recognized. So you're gonna have to install a package manager that gives you make, and I'm gonna install like Chocolatey. So if you could just look up Chocolatey package manager, and it should give you a command that installs that for you. And using that, you could just simply type chocolate install make. Um,
Those are functions that you would.
So what you could do is you could just skip make entirely and just that would help because doing has a lot of extra classes.
I'm just here to do my work, looking for a job.
Library.
Library also used to be great.
You might have to
Today there was
Okay, so assuming no one gets any errors while typing make, so you'd see a game executable file show up right here. Does everyone have a game executable file show up? Okay, sounds good. So if you type /game, you should see a window open that looks something like this. Congrats, you created your first window. Is everyone able to see that? Okay.
we have one guy.
Oh yeah, sure.
So he's not able to recognize the fact that no, but that's attention. No, the static library is already on the static library, so but in case it doesn't, you might have to compile a relative source. Line search is just on the static library. I think that was just it's on the repo, so there's maybe that you just have to download. I don't know. I don't.
No, why not? That would be
Yeah, so if you just download the source code and extract it inside the source code itself, you can open that source, and then this should generate Yep.
But when we actually pull this
So those contain the actual functions and everything that we would provide you. The static library links that to
The professor goes sometimes like so fast. It takes for me to if you want to understand how that's great.
That's right. So for your project, you may not have probably so that's why. So you only include and the static library will
Yeah, it is.
It's really computer science.
All right, so assuming everyone was able to get this window up and running, let's get started with the actual workshop, shall we? Okay. So let's. This is a really handy cheat sheet that the creator of Raylib has created for all of us to use. It essentially has all the functions that Raylib comes with, along with some descriptions on how they work. So if you'd like, you could scan this QR code using a phone or something and have that beside you just so that you can reference what functions are doing what as we progress through the workshops. Because we're going to be using a lot of different functions that Raylib gives us. You could also have this open on another tab on your laptop device. This is just for your reference material, just so you have it on the side. Okay, so let's get to the actual game. We're going to be making Snake today. It's super straightforward. It's in 10 simple steps. We're going to have a fully functioning game and have it be somewhat presentable too. So let's get started. We're first going to start with our game canvas and our game loop. So what is a game canvas? That's essentially the window that's going to be hosting our game. And it's where everything is essentially going to happen, where you're going to draw objects, where you're going to have everything, all the functionality of the game is going to be within your canvas. And a quick note about the game canvas is it's not your classic mathematical Cartesian plane. So if any of you, like the Cartesian plane is pretty common in mathematics, right? You have an x-axis and a y-axis, and the x-axis grows positively to the right, or from your POV, it grows positively to the right, negatively to the left, and the y-axis grows positively up and it negatively down. However, the only difference with the computer graphics plane is the x-axis is still the same, it's just your y-axis is flipped. So your origin, your 0, 0 is at your top left point. So the y-axis actually grows positively downwards and negatively upwards. So you gotta keep that in mind. The y-axis is just flipped, that's the only difference. So we're going to be using the computer graphics plane today for our canvas. We're not going to be using the Cartesian plane. So when we draw our game grid, we're going to be referencing points on our grid using the computer graphics plane. All right, so our game loop is essentially where the magic happens. That's where we tackle event handling, updating positions, and drawing objects. So event handling is basically when the player or like an object in the game does something, it triggers like a sort of event, and how do you want the game to respond to that? Like, suppose the snake hits the food. What do you want the game to do? Like, what do you want to happen after that? That's going to happen in your core game loop. And updating positions. So every frame of the game, you want the snake to keep moving, right? Because how snake works is the player can't pause the snake. The snake is going to keep moving. So you want those positions and all those updates to be happening within your game loop. We're also going to obviously want to draw our snake and food, because otherwise you're going to have an invisible canvas and you're not going to see anything. So drawing is also going to happen within our core game loop. So let's begin. Let's clear everything on our main.cpp. Just hit Control-A and remove it. Just get a blank slate. And let's include IO stream. So that's our default standard C++ input-output header file. Is everyone able to see this okay? Okay. So we're going to include IOStream, and we're also going to include raylib.h. So we're just going to bring those two header files in and start off with our default C++ program. So int main is the first function that the compiler is going to look for when it's building your code. So this is the starting point of your game, of your program, basically. And we're going to have it return 0. That just means the program has exited successfully, I believe. So that's just the default C++ program. It's a starting point for us to work with. Now we're going to be bringing in our first Raylib function, and it's called initWindow. And what this is going to do is it's going to initialize a window or a canvas, like we discussed earlier, for us to work with. So initWindow accepts 3 arguments, 3 parameters. It accepts the width of your window, the height of your window, and the title that you want to give to that window. So for the purposes of this workshop, I'm just going to be using 750 by 750 pixels. It is counted via pixels, and I'm going to give it the title of snake, I guess. You could call it whatever you want. You could also size it however you want, but I'm going to be sticking with this calculation because it's also going to factor into our grid. So we're going to be splitting our game canvas up into a grid, and we're going to be combining 750 pixels. Of course, when you open a window, you also have to close it at some point before the game exits. So we're going to call close window before the program actually ends. Okay, so if you try this now, so let's stop this, and let's type make /game. By the way, these are the two commands that we're going to be using to actually test our code. Make to actually compile, or as in like save the progress that we've done so far, and /game to actually run our executable and see what we've got. You'll see that it doesn't do anything, it just exits. That's because we're initializing our window and then we're immediately closing it and just exiting the program. We're not actually drawing anything. And if you remember, we're also going to be drawing stuff in our game loop, so we need to actually draw the window. And how we do this is we're going to say while, we're going to create a while loop, and the condition is going to be window should close, and that's a function, equals false. What this means is that while the window is open, so window should close, essentially is the window closed? Is that false? So that means the window is open. So while the window is open, this is your core game loop. So your game is going to run while the window is open. So while the window is closed, of course your game is just going to end. So while window open, which is basically window closed equals false, we are going to begin drawing. And of course, like we initialize a window and then we closed it, when you begin drawing, you also have to end drawing. That's standard Raylib syntax. And let's give this a test. So if we type make, allow that to compile, and then run game, you're going to see a black window with 750 pixels of width, 750 pixels of height, and a title of snake, or whatever title you chose to give it. Awesome. So we just drew our canvas, and I'm going to be sticking with a sort of green color scheme. You can choose any color scheme that you like. I'm going to type green background, or clear background, and I'm going to give it the inbuilt color of green. So Raylib comes with a couple of colors predefined out of the box. It's got a red, green, blue, and absolute value. I think that's the opacity, so how transparent the color is. I'm going to be using default Raylib colors, but if you want, you could define your own colors. You could choose the red, green, blue value. All you got to do is type color, and then my color, like whatever you'd like to call your color, and give it a RGBA value, comma separated. So A is just the transparency level, and you could define your own colors to use throughout this project. But I'm going to be sticking with the colors that Raylib gives us out of the box. So if we compile this now and take a look, you're going to see we have a green window. So is everyone with me so far? Does everyone have a green window? Okay, cool.
I got a question.
Yeah.
So in the beginning when you hash a include idle stream, there's an error.
What does it say?
It says include error. I'm not sure if it's
Can you paste that into? Have you used iStream before?
no, I haven't.
Okay, so you probably have to add it to your app.
Okay. So
Yeah, just look at it. Yeah, over there. Oh, wait, hold on. Could you just there's a question. So, oh, you have to install the C++ extension, right? So if you go to VS Code.
Oh, I haven't actually reviewed this extension.
Yeah, could you type C++? Just C++. It should be the first one.
Installed, right?
Okay, so yeah, just close.
Wait,
Yeah,
how did you?
close VS Code. Just exit from it. It should take you back to the same spot.
Oh, okay, there you go.
Just give it a second. Oh, okay, so still not able to recognize. Hold on, could you hover over it? shows you all the trends. Okay, so type control VS Code.
Like, VS
In VS Code, yeah.
Okay, so if you
I guess that would be, yeah, control command. Yeah, and type, could you go back to the search for this file.
Oh, wait, is it me? Is that
Can you go back to this?
yeah,
Search for this file. So when a pop-up showed up, you click like you might have created a file. So what you could do is you could create a dot.
Exit?
You'd have to try to
Oh, yeah, that's what it is.
and then create a C underscore CPP dot JSON. C underscore dot
Yeah, I know.
all the repositories inside the file.
Yeah, I see.
And if you go back to you could paste all the file paths out of one, which makes it more or less smart. Just go back to your CS and just scroll up. It starts with an app. So just copy everything from that app. And just paste it. Maybe you have to format it. Paste all the right now, the guy who used to play yeah, you might have to copy this exact formatting. So add a.
I have to manually type it.
Well, you should be able to copy it. By default, it creates one so yeah, it'll ask. You could copy this image and paste it into the image texting and then
Oh, okay.
yeah, but essentially you have to add this config file for it to recognize your path.
Okay, so we're just running that right now.
Yeah. But what's the actual error? Oh, it's just not in there.
Yeah, I just.
Essentially you have to just add these paths again.
Like take all this out and this in there.
With those paths. So those paths will be anything with the name replace with those. Oh yeah, and the last path. Try that. You could copy that image and you just have to look up like images. And then just copy this image. It may not be exactly
Okay, yeah.
All right. So once we've got our clear green background going, we're going to, oh, real quick. Very important, you're gonna wanna set your target frame rate. So we're gonna type set target FPS to 60. And what this is gonna do is it's going to prevent your machine from trying to run the game faster than 60 frames a second. Essentially, if you don't add this line, Raylib is gonna try and run the game as fast as it can. And of course, this is gonna throttle your laptop. So if you've got like, say VS Code running in the background, or you got Discord running in the background, those are all gonna crash and like stop because Raylib is gonna try and divert all your machine's resources to this snake window. So this line is very important. It's gonna just set a standard frame rate for your game. Okay, so once that's done, we've essentially created our canvas and we've created our game loop. Now we're gonna start with drawing our food. So we're gonna get the food on screen. And before that, we need to actually convert our canvas into a grid. So what we're gonna do is we're essentially gonna divide it into a number of cells, and we're gonna use one cell to represent a food. And we're gonna use multiple cells to represent our snake. So our snake can be like a series of cells combined, and our food is always gonna be one cell at a time. And how we're gonna do this is we're gonna define a cell size. So I'm gonna set mine to say 30, and we're gonna define how many cells we want in our game window. So I'm gonna say 25. So what this is gonna do is it's gonna make each cell 30 pixels wide and 30 pixels tall, and it's going to give us 25 cells on the x-axis and 25 cells on the y-axis. I believe if you multiply 30 and 25, that amounts to 750. So either way, we're gonna have the exact same window. All this is doing is it's dividing it into cells, basically. And we can manipulate those cells to draw our food, draw our snake, draw any element we want. And this makes life so much easier because we don't have to actually like count every pixel. We can just use cells. It's essentially scaling down our entire game to be workable with like manageable numbers. So if we go down to our init window, we can just remove 750, and in place of that, we can say cell size times the cell count. So all this is doing is, this still amounts to 750. It's just creating 25 cells with 30 pixels each. So we've got 25 cells width, and we've also got 25 cells height. So I'm just gonna copy this and paste it right here. So yeah, if you try running this again, it's just going to give you the same thing, just a classic window, except there's now an invisible grid that we can manipulate and draw food and all that cool stuff. Speaking of food, let's get to it. The way we're gonna approach this is we're gonna use classes. So we're gonna create a class called food, and essentially what a class is, it's a user-defined data type. So similar to how we have like integers, we're going to create a class called food, and that's going to give us access to some attributes and some methods that we can manipulate to draw our food or do whatever we want with the food object. So I'm going to give it the public access specifier, just so that these attributes are accessible to other classes as well. And the first attribute that we're going to give our food is a vector to position. If you think about it, our food is essentially one cell on the grid. And each cell has an x value and a y value, which represents its position on the grid. So our food is going to have an x and a y value. And this is a vector. So the way vector2 is a predefined data type that comes with Raylib. It comes with Raylib out of the box. All it does is it allows us to store an x and a y value inside of one variable. So this is very useful when we want to represent something on our grid. I'm going to give it a default position of 4 along the x-axis and 5 down on the y-axis. So that's just a starting point for our food, and we'd be able to reference these points in a little bit. I'll show you how. So our food has a position, of course, because our food needs a position. We also need to draw our food. So we're going to create a draw method, and this is going to allow us to draw our food on the grid. And there's a couple different ways you can draw things in Raylib. There's a lot of different ways. A few of the popular ones are you can draw rectangles, you can draw circles, lines, polygons, and you can also draw textures. Let's start off with rectangle, and as you can see, draw rectangle accepts 5 different parameters. It accepts the x position and the y position of the top left corner of the rectangle. So it's mapped onto the grid, and you give it the top left position x value and y value. You also give it the width and height. So from that x and y value, how wide do you want the rectangle to be? How tall do you want it to be? And what color do you want it to be? So let's say draw a rectangle, and we're going to give it the x position. So in our case, it's going to be position dot x. So we're just bringing the x value from our vector2 position that we just defined. Of course, we need to multiply this by the cell size because we want it relative in terms of our grid. If we were to just do position x, that would be relative to just the 5 pixels. So it's just going to be 4 pixels. But we want it to be 4 cells. So we're going to multiply it by cell size. We're going to give it the same for y. Oops. Position dot y times cell size. And the other 3 parameters, width and height, I just want it to be 1 cell wide and 1 cell tall. So it's just going to be cell size and cell size. So our width is going to be the width of 1 cell. Our height is going to be the height of 1 cell. And as for color, you can choose something that's preferably not green so that your food isn't invisible. I'm going to give it dark green. Like I said, you could also define your own colors if that's something you want to do. Please feel free to do so. So yeah, we've given our food a position, and we've also allowed it to draw. What we need to do now is go back to our core game loop, because at this point we've not actually created an object for it. So what we're going to do is we're going to create an object of this food class, which is going to allow us to actually call it into our game loop. And we're going to give it a constructor just so that we initialize that object. We are going to actually define a constructor at some point. Right now it's just a default constructor. And right below clear background, we're going to call our food object that we just created. So you create the food object by typing food, which is the data type, the class data type that we just defined, the food object. I'm just going to call it food. You could call it food1 or whatever you like, and then followed by the constructor of that class. And below drawing our background, I'm going to call the object that we just created, so not the class name, the object name. And I'm going to call its draw method, because every object that you create of food has a position and it has a draw method. So if I were to create another one, let's say food2, food2 would also be able to draw itself. Let's say food2. It would also have access to a position and a draw because it's an object belonging to the same class. So yeah, once we've got that done, now you should successfully see your food object on screen. So has everyone made it so far? Any questions? Yep.
Our grid's like a 25 by 25 grid, right?
Yes, 25 cells, yeah.
Yes.
And each cell is 30 pixels. You could modify the size to whatever you'd like, but these exact values are going to come into play when you're calculating. I'm going to make a border at the end, so I'm going to use values specific to 25 and 30. So you'd have to modify those values based on whatever you've used now. So just keep that in mind. But yeah, feel free to use any size you'd like. Okay, so we've created our food, but it's a green brick. It's very ugly. I don't like that. And what I've done is, if you notice, I've added a graphics folder, and I've added a PNG of this weird apple thing. I don't know. We're going to be using this as the sprite for our food. So feel free to use any sprite you like. This is just something I've included with the repository. Just bear in mind, your sprite needs to be within the size of a single cell. So a single cell is 30 pixels wide and 30 pixels tall. Make sure that the image that you're loading in is within those parameters. My Apple image is 28 pixels or something, so it should fit within a cell. Just make sure that, just account for that. That's about it. So let's bring this apple in. How we're going to do this is, if you recall, we can also draw textures using Raylib, and that's what we're going to be using to actually draw this goofy apple guy. So I'm gonna bring in a texture 2D variable, and I'm just gonna call it texture. We're also going to create at this point a constructor and a destructor. So this is specifically useful because it allows us to initialize each food object to use that texture. So essentially what constructors and destructors do is a constructor initializes the data members for the object to be able to be used in a specific state. Like you want the object to come ready with some certain things already loaded. So that's what the constructor allows you to do. And the destructor just removes all of that when the program ends or the object goes out of scope. Like if you don't need that object anymore, and let's say your texture is still being loaded in memory. Suppose the food's gone, that texture is still being like rendered, and that's gonna occupy unnecessary memory on your device, and you don't need that. And that's where the destructor comes in. It just gets rid of that. Oops. Okay, so inside of our constructor, we're first gonna call in an image variable. And what that's gonna do is it's gonna allow us to load our image in. Before we actually map to a texture, we need to load an image because textures only accept images as parameters. So what we need to do is we need to bring our image in first as an image type and then map it onto a texture. So we're gonna call the load image function that comes with Raylib, very useful. And in here, we're just gonna put 2 double quotes. We're gonna go over to our apple.png file. We're gonna copy the relative path. So just right click on that, copy relative path. It might be a little different on Windows or Ubuntu, but essentially it's the path it's not the complete path. It's just gonna be the path relative to the current working directory. And we're just gonna paste that in here. So for example, if we were to copy the whole path, it would look something like this. That would also work, I suppose, but it would only work within the context of your machine. So if you were to take this exact code and try to run it on someone else's computer, that someone else doesn't have your name or like your specific folders, right? So it's not gonna work. But if you do have a relative path, it's gonna work in the context of every machine because every repository on any machine is gonna have a graphics directory and it's gonna have apple.png. So relative paths are the way to go. Once we bring this in, we are going to essentially load this onto our texture. So we're gonna say load image from texture, and we're gonna feed it our image variable that we just created. Image to
Maybe the other way around. Load texture from image.
Oh, yeah, I used the wrong function. Sorry about that. So yeah, load texture from image. Good catch. So yeah, load texture from image. And that's essentially going to map the image that we just loaded onto your texture. Now we don't need the image anymore because we've already got our texture, right? So we're going to unload our image. So use unload image and just give it the image variable. So that gets rid of that for memory. We're playing it very memory safe here. We're trying to be as optimized as possible. That's a real advantage of C++. It gives you control over all these little things. Once we load unload our image, remember, when we get rid of our food object, we also need to get rid of the texture. So in our destructor, we're going to do unload texture. Because at this point, our object doesn't exist anymore. So at this point, we don't need our texture, so we're going to unload it. So we're just going to feed it texture. And of course, at this point, if you were to run the game, it's still going to show you the little cell. That's because we're still drawing our rectangle and we're not drawing our texture. So I'm just going to comment this out, and I'm going to bring in draw texture instead. This is all in our draw method, so that's called when you actually want to draw your food. And what does draw texture take as parameters? It takes a texture, it takes the x and y value of the top left point of that texture, and it also takes a tint. So as far as texture is concerned, obviously we already have a texture, so we're going to give it a texture or whatever you called it. Our x and y value is going to remain the same, so I'm just going to copy it from our commented out line. It's going to be the x value of the position multiplied by the size of one cell. So it's essentially going to be one cell wide and one cell tall. And as far as tint is concerned, this doesn't really matter. All it does, think of it as like an Instagram filter over your texture. It's just going to add like a color over your texture. If that's something you want, feel free to toy around with it. I'm just going to leave it as white. It's just an added feature. You could use it if you'd like. White is the default. It's not going to modify your image in any way. At this point, if we test it out, you're going to notice that little guy on our canvas. So very cool. Does anyone have any questions so far? Is everyone keeping up? Yep, okay, sounds good. So here's the thing though, if you notice, each time we run the game, like, okay, I run this, I'm gonna exit, I'm gonna run it again. The food always spawns at the same point. This isn't how Snake works. If you've played Snake, you know that this food always spawns at random points. So we want the food to spawn somewhere random each time we run the game. So let's create a function that will help us do that. We're going to create void generate random position. You can call it whatever you like. I'm going to call it generate random pos. And actually this returns a vector2. So this function is going to return a vector2 data type or a vector2 variable. And we're going to feed that to our position. And that's going to be random each time. So let's say return vector2 x comma y. So this x and y is going to be random each time we run the game, and we're going to give that x and y to our position. And how we do this is we're going to create an int x, and Raylib has this super useful function. It's called get random value. It comes out of the box with Raylib, and it allows us to give this function a minimum value and a maximum value. So it's a lower bound and an upper bound. And it returns a random value between those two bounds. So we're just going to give it the indexes of our grid, which is, our grid is zero-based indexing, by the way. It uses zero-based indexing. So if any of you have done CMPT 125 or even 120 maybe, you'd know that zero-based indexing essentially means that it doesn't start from 1 till the end. It starts from 0 and it goes to 1 minus the end, or the end minus 1. So we're going to give it a lower bound of 0 and 1 minus the end. So cell count minus 1. That goes all the way till the end. Cell count is actually outside our window. Because we're using zero-based indexing, it goes 0, cell count minus 1, and that's where the window ends. If you go to cell count, that's one cell outside your window. So this is our upper and lower bound. We're just going to copy this over, do the same thing for y. And I'm getting an error here. Oh, it's a float. Okay. So we just have to have these be float data types, not ints, because the vector struct uses float values. All right. So when you call this function, it's going to return a vector2 with a random x and y value. And what we're going to do is we're going to remove the starting position of 4, 5. We don't need that anymore. We're going to have it be random. And under our constructor, so when you're loading the food in, when you're bringing the food object in, you're going to give it that random position. So we're going to say position equals to generate random pos. That's it. And this is going to call generate random pos. It's going to get a vector with a random x and y value, and it's going to assign our position to that random value. So now if I run the game, where did it go? Let me just open a terminal. If I were to run the game now, you'll see my apple is now on the right side. If I were to run it again, oh, there he is. He's on the left side now. Very cool. So we have our food with randomized positions. Any questions so far? Everyone following along? Cool. Okay, so that's pretty much our food taken care of. And now our next logical step is to create the snake. So we're going to have our snake drawn on the game canvas. And interestingly enough, if any of you have taken CMPT 225, you will recognize this data structure. So this is something we use in CMPT 225. It's called the deck. Essentially what it is it's an upgraded queue. So a queue is a data structure that stores a sequence of values, and it uses the FIFO philosophy. So what that means is first in, first out. The first value to be entered into the queue is always the first value to be removed. And it goes in a hierarchical sequence. The deck doesn't care about any of that. You could insert at the front, remove from the front, insert at the back, remove from the back. And this is extremely helpful for our snake class, because as you can tell, we're going to be adding components to our snake and removing components to our snake based on how the game is going to how the snake is going to fundamentally move. I'll show you that in a bit. I'll explain in greater detail. So similar to our food, let's create a class for the snake. And let's give it the public access specifier. And we're going to give it a deck. So I'm going to call a deck of vector 2s. So the snake is essentially going to be a deck data structure comprised of a bunch of vector 2s. So it's going to be a bunch of cells. It's going to be a string of cells, basically. I'm going to just call this body. You can call it whatever you like. Now you'll notice we have a little error. You're probably going to get an error as well. All you got to do is bring in the C standard deck header file, and that should sort things out for you. So you just got to import or hash include deck, and that's going to bring in the deck data structure for us to be able to use. Okay, so I'm going to give this 3 vector 2s. You could have your snake start off with any number of vector 2s. I think 3 is a good starting point, and you could build on from there. If you want, you could start it with 2 or even 1 if you're a madman. Any of them works. So I'm going to give it 3, and we're going to give it the starting position. So I'm going to have it start off. I'm going to have the tail. So how this works is the 0th value is the head. Yep.
What are we including? The deck?
Yeah, so we're just hash include deck. Yeah, so it's a standard library. It allows you access to the deck's data structure. All right. Does anyone have any problems including the deck? Are you getting any errors or anything?
No, I just didn't see what you were.
Oh no, that's all good. Because sometimes even after including it, you could still get import errors or something. So does anyone have any of those, or all good? Okay, sounds good. So our 0th element of our snake's body is going to be the snake's head. So just decide on a position for that. I'm going to give it 6, 9. I'm going to make the body 5, 9, and I'm going to make the tail 4, 9. So this is going to be 6 across the x-axis, 9 down on the y-axis. Similarly, the body is going to be right next to it. So it's going to be 5 along the x-axis, and the tail is going to be 4 along the x-axis. So that's the default starting position of our snake. Of course, we also need to draw our snake. So our snake is also going to have a draw method, and we're going to keep things simple with the snake. We're not going to use textures. You'll see why in a little bit. You could use textures for snake if you wanted, but the way that we're going to move our snake is going to make it a little weird if you were to use textures. Your snake's head is going to be in the middle of its body. Trust me, I tried experimenting with this. It is not worth it. There are other ways to move the snake if you wanted to use textures. For the purpose of this workshop, we're going to have our snake be pure rectangles. Okay, so since we're drawing multiple rectangles, our snake is comprised of multiple separate rectangles. Of course, one draw rectangle isn't going to cut it. So do you guys have any ideas of what we're going to be using here? Yeah, so we're going to be using a loop. So we're going to bring in a while loop or a for loop. A for loop gives you more control over how many specific iterations you want. So I'm going to give it starting from 0 all the way to the snake's body size. So the size of the snake. But the size minus 1. So it goes 0, 1. Suppose our snake is 3 cells long. It's going to go 0, 1, 2. And that covers all 3 components of your snake. And of course, you want it to increment each iteration. Classic for loop. And inside the for loop, we're going to be drawing our snake's components. So it's going to draw however long your snake is, it's going to go over that many times and draw those components. So inside here, it's the same as the draw rectangle we used before. So you got to give it the x and y position of the top left corner of that cell, the width of that cell, the height of that cell, and the color of that cell. So just for ease of use, I'm going to assign the x and y value to its own variable. So I'm going to say body of I dot x. So that will give us the current component of the snake's x value, and similarly y value. And we can just directly feed that into the loop. You don't have to type it all out. So I'm going to say x times cell size, y times cell size. That's, of course, our x and y position. And our width and height of the snake is going to be cell size and cell size. Of course, this is each individual component of the snake, so it's all going to be one grid's width and height. And I want my snake to be dark green, so I'm going to give it that as a color. Okay, awesome. Let's test this out. Similar to how we created our food, we're going to create a snake object, call the snake constructor, and we're going to snake.draw, just like we did with the food. And let's give this a test. As you can see, we have our snake on screen. That's actually 3 components, believe it or not. You can't really tell, it just looks like one huge blob. It just looks like a long rectangle. It's not easy to differentiate each cell, and I want to fix that, right? You want, as game developers, you always want to give the player as much info as possible. Just keep things in the clear. You don't want to leave the player in the dark. So we're going to try and distinguish each cell from the other cell, just make it discernible. Like, hey, look, you can clearly tell that there's 3 cells here. It's not one giant blob. So Raylib actually gives us a function for that that's going to help in this scenario. It's called draw rectangle rounded. And what this is going to do is essentially what it says it's going to do. It's going to make each cell have rounded corners. And that's going to help us differentiate each cell from the other cell. Because right now it just looks like one giant blob of a rectangle. But if you had each cell rounded, you'd be able to tell the difference. So this accepts 4 parameters. It accepts a rectangle, the roundness of each rectangle, like how sharp or round you want your corners to be, the number of line segments in each corner. So how Raylib does this, or how it accomplishes this, is it uses line segments to actually round the edge of your rectangle. So it's depending on the number you give it, it's going to add more line segments and it's going to give you a smoother curve. However, the more line segments you give it, the longer it's going to take for it to actually compute that. However, in the case of snake, it's like super minimal. It's not going to matter that much. However, when you make more complicated games and you're using line segments to do a lot more computationally intensive things, it's going to be an issue. So just keep that in mind. And then you give it a color, of course. So I'm just going to change this to draw rectangle rounded. And the 4 parameters was rectangle, so I'm just going to name it rec. I'm going to define a rectangle called rec. It's a rectangle struct. And this is going to have the same parameters. So x times cell size, y times cell size, width and height, which is cell size, and cell size. We're getting some errors here. Again, you got to watch out for the data types. These need to be floats and not integers. That's just how the struct is defined within Raylib, so you just have to adhere to that. Our cell size value, as you can see, we've defined those as ints, so I don't want to modify those. I'm going to leave those as ints. But again, our code is not going to run because the rectangle structure wants a float, not an int. So in this case, we can use typecasting. So I'm just going to typecast this to a float. I'm going to say, hey, compiler, just forcefully convert this to a float. Only in this instance. Otherwise, count cell size as an int. Okay, so we've given it the first parameter, which is rec. It also needs a roundness between 0.0 and 0.0 and 1.0. I'm going to give it 0.5. Just meet it halfway. The number of line segments, I'm just gonna leave it as 6. It's not too high. And the color, I'm gonna give it dark green. All right, so now if we were to test this out, you'll see you can clearly distinguish each cell of the snake from the other cell. So you can clearly tell now that we have, hey, look, there's 3 cells in our snake. It's not just one giant rectangular blob, right? So that definitely helps. And yeah, so that's essentially, at this point, we've created our snake, we've created our food. Now we need to start moving our snake, right? We want to see some movement going on. So how we're going to tackle movement is pretty simple. So as you know, each cell has a position on the grid, right? So for example, 5,9, that's the body of our snake. All that movement does is you're adding a vector to it, and that's essentially going to manipulate that cell to move along the grid. So let's say 5 along the x-axis and 9 along the y-axis. If you wanted to move left, you want it to move 1 along the negative x-axis, right? So you're just gonna add the negative 1, 0 vector to it, and that's gonna manipulate that cell to move 1 minus on the x-axis. So that's effectively going to move it left. Similarly, you want to move it right, you add 1 on the x-axis. You want to move it up, you subtract 1 from the y-axis, because remember, we're not using the cardinal plane or the Cartesian plane, we're using the computer graphics plane. So the y-axis is flipped, and if you want the cell to move down, you just add 1 to the y value. Fairly straightforward. I'll put this into practice in a bit. It's going to make a little more sense. So just follow along. We're going to create a method called update. And this is where we're going to have our snake move. So essentially, the deck data structure comes with a few methods that allow us to remove and add things to it. So we're going to first remove a cell from the back of our snake using the pop back method. So we're going to be using pop back. What this is going to do is if you have 3 parts to your snake, it's just going to remove the last one. And how we're going to simulate movement is we're going to remove the last part of the snake and we're going to add 1 to the front. So it essentially looks like it's moving right to the left. So that's how we're going to simulate movement using for our snake. So we're going to pop the last element, get rid of the last element. At this point, our snake has 2 components, not 3. And then we're going to push a component to the front so that the snake looks like it's moving. So we're going to do body.push front. And of course, you need to give the snake a direction, right? The snake needs to move in a specific direction. So that's going to be a vector 2. I'm just going to go define a vector 2 called direction. And by default, I want my snake to move right. So what would right be? It would be 1 along the x-axis and nothing along the y-axis, right? Because it's just moving on the x-axis. It's not moving down or up. It's just moving right. So I'm going to give it 1, 0. And under push front, we are going to add, so this is the head of our snake, body bracket 0. We're referencing the head of our snake deck. And to this, we're going to add direction, the direction vector. And what this is going to do is essentially going to add a cell to the front of our snake. So it's going to simulate movement. Of course, you can see there's a little error here. It can't be that straightforward, can it? So lucky for us, Raylib has a sub-library called raymap, and this allows us to bring in the vector2add method. And this is going to allow us to add 2 vectors together. In our specific scenario, that's the head of the snake added with the direction. So, like so. We're going to add direction to the head of our snake. Of course, you're going to have an error here because the compiler doesn't know where to look for vector2add. So we're going to have to bring in raymap. So hash include raymap.h. Once you do that, you should be able to see that the squiggly's gone. So the compiler now knows, okay, so vector2add is part of raymap. I'm going to bring that in. Okay. Any questions so far? Any errors on? Yeah.
Sorry, what did you add on top of there again? It was
So it's raymath.h. If you notice on your directory list under include, there's raylib.h and raymath.h. So I've already provided you guys with both libraries. You just have to include it into your main file. Okay, so this essentially moves our snake, and in our core game loop, before we start drawing anything, we wanna have our snake start updating its values. So we're gonna type snake.update. We're gonna call that update method. So let's give this a run and see the snake move. Oh, it's gone. Did you guys catch that? Here, look closely. Oh, snake's gone. It's really fast. Why is this happening? Like, slow down, right? The snake is going too fast. This is because our core game loop is updating 60 times a second. And that is insanely fast. So our snake is moving. It's updating one cell 60 times a second. That is just way too fast. Our player is not going to be able to know what's going on. And we want to slow this down. So how we can do this is we can wrap it inside a conditional. We can say, hey, ignore the set target FPS thing. If this time window is passed, only then should you move the snake. Don't worry about the frame rate updates. Don't worry about the frames at all. Just move the snake if this time window has passed. So we're essentially bypassing the frame rate. So let's wrap this in the time passed function. And let's give it, say, 0.2 seconds as the window. That should be plenty of time. So every 0.2 seconds, it's going to update the snake's position. That's way slower than 60 times a second. So you'll see. We're obviously going to have to define the time passed function, so let's do that. Right at the top, below where we defined our cell count, we're going to define our time passed function so that our code knows how to use time passed, right? And to time passed, we're going to pass in a double interval. So that's going to be the value that we want to pass in. In our case, it's 0.02. And of course, how this works is if time passed is true, if 0.2 seconds has passed, only then should you update the snake's position, right? Only then should you move the snake. So since it's looking for true or false, logically this function is going to be a Boolean function because it returns a true or a false. So in here, what we're going to do is we're going to use current time and last updated time. So it's like two flags. So we're going to define double current time. And you might be wondering, how do we actually get the current time? Don't worry, Raylib's got you. Raylib has a function called getTime, so we're just going to call that. And all that's going to do is it's going to call getTime, and it's going to give you the current time. And we're also going to define double last update time. And we're going to initialize this to 0 because it starts off with 0. But then when we give it a conditional of if current time minus last update time is greater than or equal to the interval that we're giving it. So our interval is 0.2 seconds. If now minus the last time it updated is greater than 0.2 seconds, which means 0.2 seconds has passed. Essentially, this line means if 0.2 seconds has passed, we're going to update our last update time to be now. So last update time is equal to current time. And we're also going to return true. This means, yes, time has passed, therefore update the snake. So yes, more than 2 seconds have passed, therefore update the snake. Now, if it does this check and turns out last update time it's still less than 0.2 seconds, because it runs more than 0.2 seconds a frame, right? So this function is running a lot of times. It's going to return false at some point, and when it does that, we're not going to move the snake. So this when it returns false, the snake is not going to update. It's not going to move. So if we give this a try now, you'll notice that our snake is much slower, much more visible. Oh, he went off screen, okay. But you'll see it's not like zipping off screen, right? So that's ideal. Okay, Now we come to keyboard control. Of course, this is a video game. We want our player to interact with said video game. So we're going to accept keyboard input from the player. And how we're going to do this is using the Raylib function called isKeyPressed. And all that does is it detects for keyboard input, and accordingly you can have the game do whatever you want it to do. So let's go all the way down to our game loop. Right below where we're updating the snake, here's where we're going to check for player input. So we're going to do if isKeyPressed, and I'm going to use WASD. You guys can use arrow keys if you'd like, or you could do both. You could also do both. Either one works. I'm going to stick with arrow keys, or WASD. So if the key W has been pressed, we want to move the snake where? What does W do? It moves it up, right? So we want to move the snake up, and essentially that means we're going to be changing the snake's direction to go up. And what is up? It's 0 along the x-axis, because you're not moving left or right, you're going up. So it's 0 along the x-axis. And remember, we're on a computer graphics plane. So when y is going up, is it positive or negative? Yeah, it's negative. So we're going to be giving it -1. So that essentially changes the snake's direction to go up. And now you just do this 3 more times. Yep, it's just 3 more times. Remember to change these keys. So I'm going to do W, A, S, and D. Remember to change the directions accordingly as well. So for A, we're not moving up or down, so our Y is going to be 0. We're going to be moving left, right? So A takes us left, and that's -x. So -1. We're going down, so our snake is +1 on the Y, and we're not moving left or right, so 0. And if we click D, we want our snake to move right. So that takes us positively along the x-axis, and the Y value does not change at all. Okay, so let's test that out. See what that looks like. Okay, I'm gonna go down. All right, there he goes. I'm gonna go left. Okay, he's going left. Notice this. Check this out. I'm moving left, and now I want to move right. So I hit D. Oh, he just does a 180 and he flips over. Like, check this out. I'm moving left. I hit right. Oh, he just flips over. I'm moving up, and now I want to move down. I click S. He just flips over and directly does that. Any of you who've played Snake know that this is not functionality of Snake. That is not how Snake works. You have to change your axis of movement first, and then turn around. So you essentially have to do like a U-turn. So let's patch that. Let's fix that. What we're going to do is we're essentially going to add a conditional to our if. We're going to say if W is pressed, meaning the player wants to go up, but the snake is not already going down. So if the snake is currently moving down, and the player presses up, like he wants to go up, we shouldn't allow that. Like, we should block that. So if the player presses up and the snake's direction of going down, so the snake's .direction.y, so the snake's y value is not going down, so it's not equal to down, so that's positive y, right? So it's not equal to 1. So if the snake is not already moving down and the player presses W, then the snake is going to move up. But if the snake is moving down, then the snake isn't going to move up anymore, because right now he's moving down and that's not allowed, right? So we just have to copy this over 3 more times. So if the snake is moving left, we don't want it to move. If the snake is, if you want to move left, and the snake is currently moving right, we don't want to allow that. So if the snake is currently moving right, so that means positive along the x-axis. If the player wants to move down, and the snake is currently moving up, so that's negative along the y-axis, we shouldn't allow that. If the player wants to move right, and the snake is currently moving left, so negative along the x-axis. Just remember to watch out for these values, snake.direction dot, and then accordingly to the keys, it should be x or y. So that was quite a bit. I'll let you guys write this down if you have to. Take a minute, just like let that sink in. Let's give it a test. Let's check this out. So I want to go left, so I'm gonna hit A. Nope, he doesn't do it. I have to go down and then click A. He did it off screen, but yeah, he came left. Now I want to go right. Nope, I gotta go down and then go right. I wanna go up, okay, I can do it because I'm on the x-axis. I wanna go down, I'm gonna hit S, nope, he's not going down. So we've successfully patched that sort of feature out of our game. What we're gonna do next is, I'm gonna sort of reorganize this. I'm gonna create a game class, just so that we can use the game class to define our objects at the start of it. So I'm gonna create a public access specifier, and I'm gonna just copy our snake and food objects and paste it under there. So this is just gonna keep things a lot more organized, a lot more streamlined. And instead of, in our main core game loop, instead of creating a snake and food object there, we can just create a game object. And that is going to automatically create a snake and food object for us. Similarly, we can also give our game class a draw method as well as an update method. And in our draw method, we're going to, of course, draw our food, draw our snake, and in our update method, we're going to update our snake. So down here, where we're in our core game loop, instead of actually drawing our food and snake, we can just draw our game. And that's going to do the job for us, basically. Of course, these are going to change now because the core game loop doesn't know how to identify the snake object because we don't have a local snake object. We can fix this by just referencing it as an object of snake, of game. So we add game.snake.update. Or rather, since the game class already has an update method, we don't even need snake. We could just write game.update. And that's going to update the snake for us. So game.update. However, here in our directions, where we're saying snake's direction, there we do need to add the game object. So let's copy game dot, and let's paste it everywhere you see snake.direction. Okay, so this should function the same. We've just cleaned things up a bit. We've just allowed it to be easier for us to modify as we add more methods to our game and stuff like that. Okay, cool. So we've got keyboard movement. This is a huge step, big milestone, awesome. Now we want our snake to actually eat the food, right? That's one of the core functionalities of snake. So let's do that. How this is gonna work is when the head of your snake collides with the food object, you're gonna have the food just respawn somewhere else. And you're gonna increase the score value by 1. That's it, very simple. So let's take care of that in our game class. Let's do it in the game class. Let's create a new function called void check collision with food. And in here, we're gonna say if our snake.body, so our snake's head, is equal to the food's position. So if the head of our snake is equal to where our food is currently, it's going to do whatever, right? Of course, you'll see an error here because you can't directly map it or you can't directly check equalities. If you recall, we brought in RayMath earlier, right? To do vector2 add right here. Similarly, we can also use vector2 equals. And what that's gonna do is it's gonna check if 2 vectors are equal. And we can compare the snake's head to the food's position. And if they are equal, we're gonna just respawn the food somewhere else. So we're gonna say food.position is equal to food.generate random pause. And what that's gonna do is if the snake's head goes into the food, it's just gonna spawn the food somewhere else. Of course, we're also going to add our score increase, but we're gonna do that a bit later. We're not gonna cross that bridge right now. So you could leave it commented out. I'll get to that bridge later. Okay, so of course, with every new method that you add to your game class, do not forget you also have to add it to your update method. Because remember, every call of the game loop, 60 times a second, you're going to be calling update. And update is going to call everything inside that. So if you don't add this into your update function, it's not going to check for collision with food. So just make sure you add this function to update. And then yeah, you don't have to specifically call this in the game loop because update is already doing it for you, right? So you just have to define it, and then let's give that a test. So I'm just gonna go over the food. Oh, he's moved. I'm gonna go over the food again. Oh, there he goes. Yeah, so we have our food changing positions when we go over it. There's a slight problem with this, however. It's a very minor edge case. It doesn't happen a lot, but there is the chance that when your snake's head collides with the food could just spawn over the snake. Because all we're telling the food to do is just spawn somewhere on the grid, right? And that somewhere on the grid could include where the snake is. So we don't want that, that's terrible. Someone could like hack the game to make sure the food always spawns on the snake and get the high score or whatever. So let's block that functionality. How we're gonna do this is, essentially we're gonna tell, we're gonna give the food the deck of the snake's body, and we're gonna say, generate a random position anywhere except those 3 cells. So except where the snake is. So let's do that. Let's go to generate random position. We're gonna give it the body of the snake. So deck of vector 2s. And let's call this snake body for now. And instead of returning just a random vector 2 anywhere on the grid, let's assign this to, or let's leave this as is. We're going to say if element in deck, and we're going to say food.position, or rather just position, because right now we're in the food class, so you can't call an object in a class. We're going to say position, if the position is the element in this case. So element.deck, position is our element, and the deck is our snake body. So if position in snake body, then run this code again, spawn it somewhere else. We don't want it to be in the snake's body. However, as you can tell, we're repeating code. As good, diligent developers, our job is to prevent duplicate code. So if you see any code ever getting duplicated, put it in a function. Just put it in its own function. So we're gonna create a new vector2 function called generate random cell. So what this is going to do is it's going to generate a random cell somewhere in our grid, and we're just going to paste that in there. So it's going to return a random vector 2, and inside our generate random position for our food, we're going to say vector 2 position, and we're going to call generate random cell this time. So we're going to have position generate a random cell on the grid. Just get a random position from the grid. And if that position happens to be in our snake's body currently, do it again, right? So position. This time we don't add a vector 2 because it's already been defined. Generate random cell. And you might be wondering, what if it happens again? Of course, this is super unlikely. It's not going to happen twice. It's not even going to happen once, but we have to take care of it, right? What if it happens again? This if is only going to check for it once. Well, remove if, make it a while. Problem solved. As long as the food's position is in the snake's body, it's going to keep generating a new position until it's not. And finally, when the food's position is not in the snake's body, then you return the food's position. So that takes care of that little edge case. You might be wondering, hey, look, element in deck isn't defined. So yeah, that's a function we need to create. So let's go all the way back up and let's define that function. And what this is going to do is it's going to tell us true or false. Is element in deck? Yes or no. So of course that's going to be a bool, element in deck, and it's going to accept a vector 2 element and a deck of vector 2s called position, or deck rather. let's just call this deck. So we have our element, which is a vector 2, and we have our deck, which is a deck. And what we're going to do is for each element in that deck, so we're going to have in a for loop, and this is going to go all the way till the size of the deck. So we're going to do deck.size I++. So we're going to iterate over our deck, and we're going to check, is our element in that deck currently? So if you'll remember vector 2 equals that we brought in from RayMath, we're going to be using that again. So if vector 2 equals and our element, if our element equals our deck's current value, so deck of I, so the current value in our deck, the current component, if they're equal, return true, because yes, our element is in that deck, right? If it goes through this entire loop, and if it finds out, hey, look, element was not in the deck anywhere, return false. No, element was not in the deck. So yeah, that's all that's going to do. You're not going to see any difference in gameplay because it's still the same game, but now we know for a fact our food is never going to spawn on the snake. So we've taken care of that edge case. However, you're going to get a couple errors because if you remember, in our food constructor, we actually call generate random pause, and now the function signature has changed. Generate random pause doesn't just have empty brackets anymore, because when we define generate random pause, it accepts a deck. So we're going to have to change that at every instance. So we can't just paste the deck in here. We have to feed it to the constructor first, and then allow this to call on that snake body. So we're going to change our constructor to accept a deck, and then give that to our spawn position, so that it can use that to compare. And where else do we have an error? We've got an error here. So again, we're going to feed it the deck that we want. The deck in question happens to be our snake's body. And we go down to collision with food. There's an error here. So again, snake.body. Yeah, it's one more error apparently. Oh, I guess not. Okay, so no more errors. Let's run. If you run that, it's going to be the same thing, except you know for a fact now our food is not going to spawn on our snake ever. Cool. So we took care of that using this handy function that we just defined. All right, so congrats on making it this far, by the way. It's pretty much almost the whole game. We have a couple more steps to go. We're almost done. We now need to grow our snake. So every time your snake eats the food, it needs to grow in size, right? And how we're going to do this is every time the snake's head collides with the food, we're going to add a component to our snake. We're not going to move it for that iteration, for that update call. We're just going to increment a new component to it. So we're going to add one and then not move it. So what we're going to do is we're going to go to our snake class, and under update, we're going to say if add segment. So before that, let's define a new Boolean value called add segment. All this is going to do is it's going to tell, it acts like a flag. Should we add a segment to the snake or no? And I'm going to initialize it to false. So by default, no, you don't add anything to the snake. If by chance it happens to be true, then yes, you do want to add something to the snake, right? So you're not going to remove anything from the snake. So you're not going to call pop back. You're only going to call push front. So we're not removing anything from the snake, just adding a new one to the head of the snake. And of course, if add segment is false for this update call, then you just, as usual, you just move the snake. You just do it as normal. The snake is just moving. Remember my point about good developers never repeating code. So as you can tell, in both cases, we have some repeated code. No, we're just gonna put that outside because it's gonna be in both if or else anyway. So we know that line's gonna run. So what's the point of having it there twice? Of course, if its add segment is true, we have to turn it back to false. Otherwise, your snake is, for each update call, your snake is going to keep growing. So it's going to be like infinity long in a second. So we're going to just turn this back to false. Okay, cool. Now, the question is, when do we want add segment to actually be true? When it collides with the food, right? When it collides with the food, you want to actually grow the snake, not when it just like randomly moves into air or something. So we go back to check collision with food, the function that we defined in our game class, and if our snake's head is equal to the food's position, of course we're going to move our food somewhere else, and we're also going to turn add segment to true. So now, yes, you should add a component to the snake. This is a method, it's an attribute of our snake, so we're going to say snake.addSegment because it belongs to our snake object. And yeah, so this should add growth functionality to our snake. So we go over the food, now he's 4 cells. We go over the food again, oh, he's 5 cells now. So yeah, we're having our snake successfully grow by 1 cell each time he collides with the food, and he's not moving for that call of for that game call. Okay, everyone with me so far? All good? Any errors or something? Okay, sounds good. Now comes the real kicker. So we're gonna have to do collision. This is the part a lot of game developers don't like because there's a lot of different physics stuff involved. But let's get through it anyway. There's 2 collisions that we have to check. We have to check if the snake collides with the wall, obviously, and we have to check if the snake collides with itself. So let's tackle wall first. Essentially, how we're going to do this is if the snake's head goes beyond any of those window edges, then end the game. Just kill the game. Like game over. The player's lost, right? So let's do that. In our game class, we're going to create a new method called void check collision with edge or wall or anything, whatever you'd like to call it. And how we're going to do this is if snake dot head, so body 0, if the snake's head's x value is equal to cell count, which means, remember, our grid spans from 0 to cell count minus 1. So if our head is equal to cell count, not cell count minus 1, cell count, that means it's 1 over our grid's, our edge, which means it's out of bounds. So that's a condition we have to look for. Or, so that's the or operator. If our snake's head, x value, is equal to minus 1, which means cell count is the right window, so it's looking for the right bound. Minus 1 is the left window. So if it's like, if the snake happens to go beyond the left window, of course, this is only left and right. We also need to check up and down. So let's do that. Or, so we just copy this. Let's just copy this entire line. Paste it right here. Change x to y. That's it. All this is doing is it's checking if it's minus 1, which means the top, if the snake's head goes over the top of the window, or if the snake's head goes below the bottom of the window. So if any of these conditions are triggered, game over. We're gonna define that function in a little bit, but if any of these are triggered, we're gonna end the game. Now you might be wondering, what is game over? Game over can be defined by you guys. You can define whatever you want. I am going to define it as returning the snake to the starting position. I'm going to randomize the food again, have the food spawn somewhere else, and I'm going to pause the game. So the snake isn't going to move. It's just going to stay still. Of course, you can have your game over condition be whatever. You could just close the game. If you really hate your player, you could just like quit the game itself. You can have it do whatever you'd like. This is what I'm going to be doing. So feel free to follow along with me if you'd like. So let's define our game over function. Void game over. And like I said, we're going to reset the snake's position. So I'm just going to call reset. This, again, isn't defined, so we have to define it in our snake class. So let's go back to our snake class, create reset. That's a method that we're going to be calling in our game over function. And what reset is going to do is essentially you're going to move the snake back to its starting point, right? And all that means is that we reset the snake's direction and its body position. So just copy these 2 lines and paste it in reset. That's it. Get rid of vector 2 because direction already exists. So yeah, just body and direction. That's it. We're resetting it, basically. And so 1, we're resetting the snake. 2, we're spawning our food somewhere else, right? We're respawning our food. So food.position equals to food.generate random pause. Of course, you have to give it the snake's body as a parameter. So yeah, our snake has been reset, our food has been respawned somewhere else, and we also need to pause the game. So what I'm going to do is I'm going to create a flag called is running, and that's going to be a Boolean flag. All this is going to do is it's going to tell the game, it's going to check, is the game still running or no, true or false, right? I'm going to initialize it to true. By default, yes, the game is running, unless you give it a reason not to, in which case it changes to false. And when game ends, we're going to say is running equals to false. All right. When does, so is running remains true, and in our update call, we only call these updates if is running is true. So, by the way, there's something I missed, which remember I asked you to keep an eye out for. Every time you define a function, make sure you put it in the update call if you want it to be called in each call of the game's frame rate, basically. So we need every call of the game's update function, we need to move the snake, we need to check collision with food, and we need to check collision with edge. So, oops, let's, yeah, there we go. With edge. Okay, so we're just gonna paste that there. We don't wanna end the game every call of update, so we're not gonna add game over in there. That wouldn't work. We're only calling game over if some condition is met. So this should take care of our game ending. Of course, this only happens if the game is running. So if is running is true. So we go to update and we type if is running. You could say equal to true if you want, but by default you could leave it as if is running, and that's going to do the same thing. And in here we're going to put all our update methods. So snake.update, check collision with food, and check collision with edge. So only if the game is running. Of course, if is running is false, it's not going to do any of these things. It's not going to move the snake. It's not going to check for collisions or anything. So we've got that. And we want our game to start back up if the player clicks an input, right? So if any of these inputs are clicked, we want to set is running back to true. So if it's currently false, set it back to true. So this is an attribute of the game class. So make sure you add the game object and just paste it under each key's if conditional clause. Yeah. And what that should do is if, let's test this out real quick. So make ./game. If the snake collides with any of these borders, oh, not only has the snake reset its position, the food is randomized, and the game is paused, so it's not moving. But if it accepts an input from me, the game starts back up again. So that's how I defined my game over. You can define it as however you'd like, or stick with this. That's all well and good. Okay, that tackles one collision. Now, we also need to check if the snake collides with itself. Forgive my horrible Photoshop. Don't look at that. So if the snake collides with itself, right? So again, we create another method in our game class called void check collision with itself. Let's just call it itself. Check collision with itself. Before we forget, make sure you add this to the update method, just so that it's also checking for collisions with itself, each call of update. Now, checking collision with itself is kind of interesting. How we're going to do this is we're going to clone the snake, we're going to remove the snake's head from that clone, and we're going to say if the player snake moves into the clone snake, if the player snake's head is within the clone snake's body, end the game. So that's kind of how, it's a bit strange, but it works. So here's how we're going to do this. We're going to define a new deck of vector2s, same as our player snake. We're going to call this headless snake. You could use a little bit of a less grotesque name if you'd like. I'm going to call it headless snake. And we're going to initially assign this to the player snake. So we're going to say initially, it's just snake body. But what we're going to do now is we're going to say headless snake dot pop front. So we're going to remove the head from headless snake. So now it's the player snake without the head, right? Once we do this, once we remove the head from the snake, the copy, we're going to say if vector2 or if element in deck. Remember this function that we defined earlier? It's going to come in handy again. If element, oops, where was that? Game class, yeah, right here. So if element in deck snake's head, so our player snake's head, snake.body 0. If our player snake's head is in the headless snake. So if it's in its body, then why is this not meant? Did I get rid of it? Oops. I might have removed the function. There we go. So yeah, if element in deck, and we're just going to check if the snake's head is inside the headless snake's body. Yeah, and if that's the case, end the game, right? Because essentially your player has collided with itself. So fairly straightforward. We don't have to define game over again because we already did. And let's test that out. See if it works all right. We need to grow the snake a little bit, so let's get our snake to about 5 or maybe 6. I think 6 should be fine. Okay, now we're gonna try and collide with ourselves. Oh, okay, so it does work as intended. The snake ran into itself and the game ended. Cool. So we've got both collisions taken care of. At this point, snake is done. Your game is ready to go. The core game is functional, so congrats for making it this far. Awesome. We're just going to tidy up a bit at this point. I'm going to add a title. I'm going to add a frame, add a border. I'm going to add some sound effects. I'm going to add a score. Of course, you can't have the game without the score, right? You need to keep track. So we're just going to polish up a bit, and you'd have a fully functional, presentable snake to go. So, but the core game at this point is ready to go. It's fully functional. So let's start off with adding a title and a frame. So let's start off with the frame. What I'm going to do is I'm essentially going to widen our canvas a little bit, and I'm going to make the playable area within a border. So let's start off by adding an offset value. So where we defined our cell size and our cell count, I'm going to add an offset of, say, 75 pixels. And if you go back to where we defined our window, where we started this whole thing off, we're just going to add 2 times the offset to both our width and our height. So we're adding 75 pixels to the left and to the right of our width, 75 pixels to the top and the bottom of our height. So let's say 2 times offset plus cell size times cell count, 2 times offset plus cell size times cell count for our width and our height. So if you run this now, you'll notice our game window is slightly larger. It's a little bit bigger. Cool. Now we also want a border within our actual game window. And how this is going to work is, so let me explain. The offset is essentially added beyond the game margin. This is how we've defined our window. So you've got an offset on both sides. And this is your playable area. So cell size times cell count is the middle portion within the black dots. And our border, we're going to use a function that Raylib gives us. It's called draw rectangle lines x. Essentially what this does is it draws a rectangle, but it doesn't actually fill it in. So it's only drawing the border. Everything else is transparent. It's very useful for drawing borders, basically. So we're going to go down to clear background, and below clear background, we're going to say draw rectangle lines x. And of course, this accepts a rectangle. Let's see what it accepts. A rectangle, the thickness of your border, so I'm going to say 5 pixels thick, and the color, I want it to be dark green. Oops, yeah. Okay, but what is rectangle, right? How big do you want that rectangle to be? So let's define that. I'm gonna call it rec, and this is going to be offset minus 5, so that's basically 75 pixels this way minus 5 pixels. So you want it to start from right over here. This is 75 pixels wide and minus 5 pixels, right? So this is where it starts from. Same for this. So same for the width and height. So we're going to have offset minus 5, offset minus 5. Keep in mind these all need to be float values, so we're going to typecast these to float. We're just forcefully converting them. And our rectangle also needs a width and a height. So it's going to be cell size times cell count plus 10. So essentially that means this is our playable window, cell size times cell count. We're adding 5 for the thickness of our margin here, 5 for the thickness of our margin here. So cell size times cell count plus 10. So let's just add that for our width and our height. That's cell size times cell count plus 10. Just copy that. And that's also going to be our height. Of course, this needs to be typecast as well. So float, float. Awesome. Let's check this out. Let's see what it looks like. And as you can see, we now have a border and a playable window within our game. But look, check this out. Our snake is going to go over the border, so it still thinks that our original game window is still the bounds, right? It's not colliding with our new wall. That's a very simple fix. We're going to go over to where we define our snake, where we're drawing our snake. So go to our snake class, go to draw, the draw method, go to draw rectangle rounded, or rather the rectangle, and just add offset to it. We're just going to add offset to the starting X position and the starting Y position. Similarly for our food could spawn outside this box. We don't want that. So let's go over to where we're drawing the texture and add offset to the position.x times cell size and position.y times cell size. Just add offset to those. Now you'll notice when we run the game, our snake is going to collide with the wall clearly. Yep. And he's going to collide with this wall. Yep. So we've fixed our borders. That works. Now we're going to add a title, right? You want to add some text, make it look cool. Raylib has a function called draw text. So we're just going to call that. And draw text takes 5 parameters. It takes the text itself. So I'm going to call it DNS Raylib or DNS Raylib Workshop snake. It's a little long. You could call it whatever you'd like. We're also going to have this X position and the Y position of where the text is going to start from. So I'm going to have that be offset minus 5, which is the X value. So I want it to be 75 pixels minus 5. So it starts from 70 pixels along the X-axis. And Y, I don't want it to be too low, so I'm going to say around 20. And you also need to give it a font size. 40 is a good value. And a color. I'm going to give it dark green, as always. Okay, let's see what that looks like. Okay, there you go. You have a title on top. It's offset minus 5 on the X, 20 pixels down, and it's got a font size of 40. Of course, we need a score at this point. So let's do that. Very simple. Essentially, our score starts with 0. If the snake collides with the food, the score goes up by 1. If the game ends, the score resets to 0. That's it. That's all our score is doing. So let's go to our game class. Let's define int score equals to 0, because our score is a number. It's an integer value. Let's go to collision with food. So if the snake collides with food, we want our score to go up, right? So score plus plus, our score is going up. You could also do score equals to score plus 1. This is just an increment. It works the same. We go to game over and we say score equals to 0. So when our game ends, we reset our score, right? We don't want it to continue having the same value. So score equals to 0. Of course, we need to draw our score, otherwise we're not going to see it. So let's go back to where we drew our title, and let's add another one called draw text, and let's use this for our score. However, you can't just draw a string, right? Because our score is a changing value. The number keeps changing. It's not a fixed value. So we're going to use Raylib's inbuilt function called text format. And if any of you have ever used C, not C++, C, you'd know there's a function called printf. And what this does is it allows you to give the function data type specifiers or something like that. And what that does is it allows you to print a moving or a changing value. So for example, in this case, since we're printing an integer, which is score, we're going to give it %d, and that stands for decimal or integer or whatever. And that's going to print our score, or no \n rather. Score is undefined. Oh, so game.score, because it's a property of our game class. And so that's our text. And then of course, x value, I'm going to have that be, I want my score to be on the top right. So somewhere here, since we have our game text right here, I want my score to be here. So it's going to be offset plus cell size times cell count. And then I want it to be a little to the left, so minus maybe 10, right? So let's do that. I'm going to say offset plus cell size times cell count minus, say, 15 maybe. You can play around with these values, see what you like. You could even position it on the bottom if you want. This is all left up to you. You can decide how you'd like it to go. Font size, I'm going to give it 40. And I'm going to give it a color of dark green. Let's see what that looks like. Oh, why am I getting an error? Oh, right. Yes, thanks. So the y value is just going to be 20. I want it to be aligned with the rest of the text, so it's going to be the same exact y value as our title. Okay, so let's check this out. And there you go. You have a score on top. I'm going to just see if it works as it's supposed to. Oh, 1 and 2. Okay, good. We know the score is working. Awesome. Finally, just as a finishing touch, I've added some sound files for you guys to use. Just to, just a little cherry on top. No game is complete without good audio. So all we're going to do is we're going to create a constructor and a destructor for our game class. So go to your game class, create a constructor, create a destructor. And how we're going to do this is, you'll notice right here on the left, I've got a directory called sounds, and we've got two sounds, eat and wall. So you can put two and two together. I'm sure you know what they do. In our constructor, when our game is created, when our game object is created, we're going to init audio device. This is going to initialize our game to start playing sounds. And we're going to say load sound. So before that, let's define two sounds. Let's say sound eat and sound wall. And we're going to say eat is equal to load sound, and wall is equal to load sound. And in here, just like how we loaded the textures, we're going to copy the relative path of our sound files. Copy relative path. For eat, put that in eat. Copy wall, the relative path, put that in wall. It should just be sound/name.mp3. So we're going to load these sounds in our constructor. And in our destructor, once we're done with our game, we don't want our processor to still use those sounds. So we're going to unload sound, eat, unload sound wall, and we're going to close our audio device because we're done with it. We don't need it anymore. Now we actually need these sounds to play when certain things happen, right? So when our snake collides with the food, what do we want to play? Wall? No. Of course we're going to play eat, right? So check collision with food. Our snake has collided with the food. We play sound. Which sound are we going to play? Eat. And you can play the wall sound by just hitting the wall, If you want, you could also have it play when it hits itself. So I'm gonna have it play when it does both. So in that case, I just have to put it in one position, game over, because I know that's gonna count both the walls and itself. If you want, you could have it be only the wall. In that case, just put it in check collision with edge. So I'm gonna say play sound wall. With that, let's give this a final test. Let me increase the volume. And let me run over the food. Oh, you got the food. Let me run into the wall real quick. Oh, yep. And with that, thank you everybody for joining DNS and Game Dev Workshop, Raylib Part 1. I hope you guys learned something useful. C++ can be a little intimidating. You can do things a lot faster with Python, but it gives you so much unparalleled control over your actual game, and it's second to none. So I'd like to credit Programming with Nick, the YouTube channel. I highly, highly recommend you guys check that channel out. He's got lots of awesome resources on Raylib, so highly recommend you check that out. And stay tuned for Workshop 2. We'll be building a different game. Stay tuned for that. I'm not going to announce that yet. But yeah, thank you guys for joining. I hope you gained something useful from this.